My name is Emil Montoya. Alright, so what we're going to do is, I already did that, it's not going to be funny now. Alright, so we're going to talk about how we came up with each unit, length, volume, and mass. Here we go. Alright, so what we did is we took and we put a red line on the equator, and we put another red line at the North Pole, and I can't remember if it was North or South Pole, but it doesn't really matter for the sake of illustration. And then, and we didn't really put a red line, so if you really believe that, you shouldn't. What we did from there is we drew another line in between. Ooh, that's getting a little big there. Let's get that a little small. That's a little bit redunculous. Okay, we drew a line between. What? Okay, we're keeping the big black line. We drew a line between the two, and then we cut that into. Now I can't really do this. Yeah, but we put 10,000 of them in there. So we basically divided the space here by 10,000. And when we divided the space by 10,000, we ended up with a certain length. Each of these little spots would be a certain length when we did that. Anybody guess what that length would be? This long right here, 1 meter. That's how we came up with the meter. Okay? So, we now called that the meter. Boom. Woo, there it is. Woo, there it is. The meter. Okay? Now, that's how we came up with length. But then in the metric system, we just started dividing things by tens, and then we came up with subunits. So if I divided this by 10 and then 10 again, I would end up with centimeters. And if I divided it, the whole thing by another 10, or a total of 1,000, take a meter divided by 1,000, you end up with millimeters. So we just divide it in smaller units and on multiples of 10. I'm just going to talk about one of those multiples today. I'm going to talk about dividing it by 100. Okay, and if we divide it by 100, we end up with the length of a centimeter. Okay? Now we have a way to measure length, the distance between two spots, right? Okay? But now we want to be able to measure volume. So here's what we did. We took this centimeter and we built a box. So that box measures 1 centimeter by 1 centimeter by 1 centimeter. Does that box take up space? Yeah. By its very definition of it being a box, it's taking up space. And we decided that we would take and measure dimensions 1 times 1 times 1, and we would now use this unit called the centimeter cubed to measure space. Usually for solids. Now, we could also measure in meters cubed, or decimeters cubed, or millimeters cubed, but I'm just talking about centimeters cubed. So we have a way to measure space. Then what we did is we took this box and turned it into water. Poof, it's water. And we dropped the contents of that liquid into a test tube. Now, we didn't really do it this way, but to get the idea. So we took the liquid, and remember I showed you that the other day, remember? When I dropped the actual box in there and the water went up, okay? But you take that and you turn it into a liquid, and now the liquid is sitting in the test tube. And we put a tick mark at the bottom of the meniscus, and we said, let that be the same as a milliliter. So now we have a new unit called a milliliter that we use for liquids. So really, a centimeter cubed and a milliliter are the exact same thing. There is no difference between those two units. They're identical to each other. We just tend to use milliliters for liquids, and we tend to use centimeters cubed for solids. Now, If I had 1,000 of those little milliliters, I would end up with a whole liter. So we also have liters, and we could even have kiloliters, and you just add a prefix to it, and that tells you how many of it you have. Okay. All right, so now we can measure length, now we can measure volume, but we still don't have a unit to measure mass. Okay, but I did explain it to you yesterday, but I'm going to go ahead and explain it again today. So what we did is we built a teeter-totter, and we poured the water onto a teeter-totter. Now, pretend the water doesn't run off the teeter-totter. And then we put a little slider on the teeter-totter that you could slide either direction. And if we slide it far enough, the teeter-totter balances so that my water is now being balanced by this mass that I slid over to the right. And we put a tick mark there. And don't forget that this is only, don't forget that this is only 1 milliliter of water. That's the volume of the water, the volume. But we put a tick mark on our balance, and guess what we called it? 1 gram. That's how we came up with the gram. Easy peasy lemon squeezy. And if I had 2 milliliters of water, if I added another milliliter, so I had 2 milliliters of water, we'd have to slide the slider over a little further, and we'd put a tick mark, and we'd write a 2 there, and now we have 2 grams. So the gram is actually based on the amount of particles in a milliliter of water. Okay, a gram is based on the number of particles in a milliliter of water. All right, well, thank you for playing. Thank you for listening. If you're listening to this online, I'm super excited for you.